Imagine for a moment that you are looking at one of the most famous ancient epics in human history.
Right, like a massive sprawling text.
Exactly, yeah. A text that is universally filed on library shelves under like mythology or poetry or, religious scripture.
Something you read for the characters and the battles.
Yeah, exactly, for the grand battles and the dramatic dialogue and all the heroes and villains. And you're reading along, and then suddenly you realize something profound.
Something that completely shifts your perspective.
Right. You realize you aren't just reading a story, you are actually looking at the raw data log of a cosmic plane crash.
I love that description. It really is a plane crash.
It is. You are holding a literal, precise astrophysics manual that is meticulously recording a catastrophic event in our solar system, and it is entirely disguised as a poem.
And that fundamentally breaks the lens through which we view ancient history. I mean, when you stop reading these texts for their metaphorical value and start reading them for empirical data, the entire document just transforms right before your eyes.
It's wild, and that is exactly the paradigm shift we are exploring today on this deep dive.
We have some incredibly dense and fascinating material to go through.
We really do. We have this fascinating and honestly mind-bending stack of research documents and translated notes centered on something called the Yugantar model.
Right, the Yugantar model, which is the key to all of this.
Yeah, and our mission today is to use these specific sources to completely reframe how you look at the Mahabharata.
We are going to decode this ancient Indian epic, not as a mythological story of warring cousins, but as a hyper-precise record of astronomical mechanics.
We're talking gravitational torque and planetary orbital shifts. It is just nuts.
And what makes the sources we are looking at today so compelling is that we aren't just imposing modern scientific concepts onto an old text to make it sound cool.
Right, we aren't just cherry-picking stuff that sounds like a spaceship or whatever.
Exactly, no. We're using the text's own internal numbers, its own stated dates, and its own durations to prove that the authors were recording a physical reality.
They were tracking events that modern astronomy is honestly only just beginning to grapple with.
Yeah, they really were. It's incredibly advanced.
So before we get to the massive war and all the chaos, we really need to set the stage. We need to understand what the solar system looked like before this cosmic crash happened.
The baseline setup is absolutely crucial here if we want to understand the scale of the disaster.
Right. So according to the research in our sources, in the Dwapara Yuga, which is the era right before the great shift into our current era, the Kaliyuga, the Earth's orbit, and the Moon's orbit were operating on a completely different set of mathematics.
Yeah, according to the Yugantar model's extraction of the ancient data, in this Dwapara Yuga, the Earth's orbit around the Sun took exactly 360 days.
Not the 365.24 days we experience now.
Right, exactly. Not 365, a perfect symmetrical 360 days.
Wow. Okay, that alone is a big shift.
It is, but the more critical metric for our deep dive today actually involves the Moon.
Right, because the Moon's speed and its orbit around the Earth were entirely different in that era.
Yes. The Moon's journey across the sky was much, much slower. And to track this, the ancient astronomers used something called Nakshatras.
Okay, let's unpack this. For anyone listening who might not be familiar with Vedic astronomy, what exactly is a nakshatra?
So a nakshatra is basically a lunar mansion. If you imagine the path the Moon takes across the sky, the ancient astronomers divided that path into 27 specific sectors.
Like 27 star constellations along the Moon's track.
Exactly. Now today, in our current era, the Moon takes roughly one single day to cross one of those nakshatras.
Right, so it moves through one sector per day.
Yeah.
Very familiar, very steady.
Yeah, a very predictable pace. But the baseline data from the Dwapara Yuga tells a vastly different story.
This is where the math gets crazy.
It really does. In that era, the Moon took exactly 4.709 days to cross a single nakshatra.
I just want to let that number sink in for a second for the listener. 4.709 days.
It's a huge difference.
The Moon was just taking its time. It was majestically, slowly gliding across the sky, taking nearly 5 times as long to cover the exact same distance it covers tonight.
Precisely. The orbit was wider and the physical speed was much slower. Time and movement in the heavens stretched out completely differently.
Almost like moving in slow motion compared to now.
Yeah, and this 4.709 days per nakshatra metric is our anchor point. It is the steady, resting heartbeat of the Dwapara Yuga.
Okay, so if this calm, slow 4.709-day lunar pace was the baseline, what in the world happened to the math when the Mahabharata War broke out?
Well, everything fell apart.
Because the text describes utter chaos. And I guess the bigger question is, why does decoding this math matter to how you and I understand human history?
Right. Well, to understand the chaos of the Mahabharata, the truly apocalyptic scale of the war, we first need to understand the physical celestial event that triggered it.
Which our sources refer to as a cosmic gear shift.
Yes, a gear shift.
Now, a gear shift implies a physical mechanism, right? Like it implies massive interlocking forces grinding against each other in space.
Exactly. The Yugantar model's core premise is that the transition from the Dwapara Yuga into the Kaliyuga wasn't just a change in human morality marked on a calendar.
It wasn't just society getting
No,
worse.
it involved a massive, terrifying gravitational torque.
Yeah.
We're talking about an actual 180-degree flipping of the solar system's axis.
Just a total inversion.
Yes. Think of the solar system's mechanics at that time as a giant bevel gear.
A bevel gear. Okay, for anyone picturing it right now, a bevel gear is like the gears you see in the differential of a car, right? Or maybe inside a hand drill,
Yeah, that's a great example.
where the gears meet at a 90-degree angle or an angled intersection, and they're specifically designed to change the direction of the rotational force.
Exactly. Now imagine the immense gravitational pressure required to take a planetary bevel gear and physically flip it 180 degrees.
I can't even fathom the forces involved there.
It's staggering. As this cosmic gear began to flip, transitioning the solar system into the Kali Yuga, an incredible amount of gravitational pressure was exerted on the Earth and the Moon.
And the sources point to a very specific source for this pressure, right?
Yes, they point to the influence of the L2 Lagrange point, which is conceptually linked in these ancient texts to the entity known as Rahu.
And this pressure fundamentally altered the mechanics of the Earth-Moon system.
It completely broke the old system.
Okay, wait, hold up a second. L2 Lagrange point. You just dropped some really heavy orbital mechanics on me there.
I know it sounds very technical, but it's important.
If I am picturing the Earth and the Sun in space right now, where exactly is this L2 point, and how is it applying gravitational torque?
It is a great question, and we absolutely need to clarify the physics here.
Yeah, let's break it down. And also, how does this connect to Rahu? Because usually Rahu just gets written off as like a mythological demon that eats the sun during an eclipse.
Right, which is the standard interpretation. So in orbital mechanics, a Lagrange point is a specific position in space where the gravitational pull of two large orbiting bodies, like the Sun and the Earth, precisely equals the centripetal force required for a small object to move with them.
So they're essentially like gravitational parking spots in space.
Exactly. There are zones of stability, and there are 5 of them in any two-body system.
Okay, so where is L2 specifically?
The L2 point sits directly behind the Earth on the exact opposite side of the Sun.
So if I'm looking at the sun from Earth during the day, L2 is directly behind my head out in the dark of space.
Yes, exactly. It is a point of immense gravitational balance, but it's also a point that can harbor intense gravitational influence if the geometry of the solar system shifts.
And how does the ancient concept of Rahu fit into this?
Well, in Vedic astronomy, Rahu is often described as a shadow planet that causes eclipses. Modern scholars dismiss Rahu as a myth or a metaphor for the ascending lunar node.
Right, just a mathematical point with no physical mass.
But the Yugantar model aligns Rahu with this actual L2 Lagrange node. When the solar system began this massive transition, this gear shift, the gravitational dynamics shifted completely.
So the parking spot became an active force.
Exactly. The pressure from this L2 node, this Rahu point, exerted an extreme pulling force. It applied a literal torque on the Earth-Moon system.
So if the solar system is essentially undergoing an axis inversion wobbling and flipping due to this unseen gravitational pressure from L2, what does that actually do to our slow, majestic moon?
The one that is taking 4.709 days to cross a star sector.
Yeah. How does it react to that torque?
It brings us to a fundamental law of physics. The law of inverse proportions regarding speed and time combined with the conservation of angular momentum.
Okay, walk me through that.
As the gravitational pressure from the L2 point increased, the moon's orbit was physically squeezed.
Like compressed.
Yes. It was compressed from a wider circle into a tighter, much more elliptical shape.
So the track was running on got much smaller.
Exactly. And because the orbital track shrank, but the energy of the entire system had to be conserved, the moon's speed drastically accelerated.
Let me make sure I'm visualizing this correctly. The physical speed went up, which means the time it took to cross a star constellation went down.
That is correct.
If you are listening to this right now and trying to picture the moon speeding up, think of it like a figure skater.
That's the perfect analogy.
You know when they are doing a spin on the ice and they have their arms stretched wide out? they spin relatively slowly.
Right.
That is our Dwapara Yuga baseline, 4.709 days. But then they pull their arms incredibly tight to their chest, the radius shrinks, and suddenly they are spinning exponentially faster. They become a blur.
You do.
So the moon's orbit shrank, so the lap times got drastically shorter.
That is the exact mechanism the moon pulled its arms in. And the data we have in the sources tracks this acceleration curve perfectly.
It's amazing that we actually have the data for this.
We do. So we started the baseline of 4.709 days per nakshatra. Now, the Yugantar model operates on a specific cyclical ratio, the 1.2.4.8 ratio of the yugas.
Okay, let's break that down to what does that ratio mean in terms of the physical speed of the moon?
So in the ancient texts, time is cyclical. It moves through 4 distinct eras, or yugas.
Right.
This 1.2.4.8 ratio represents the proportional duration and the intensity of the gravitational tension in each of those eras.
Okay, I'm following you.
As the solar system plunges into the extreme depths of the Kaliyuga, which is the most intense era representing the 8 in that ratio, the gravitational pressure reaches its absolute maximum.
So things get as squeezed as they can possibly get.
Exactly. Because the pressure essentially doubles from the previous baseline, the orbital velocity peaks, meaning the time it takes to cross a nakshatra drops by exactly half.
Okay, let me do that math. Half of 4.709, that takes us to roughly 2.354 days per nakshatra.
Correct.
That would be the absolute fastest point, the peak of the Kaliyuga's extreme velocity.
Precisely. But the Mahabharata War didn't happen at the absolute bottom of the cycle.
Right, it was a transitional event.
Yeah, it happened during the violent transition period right in the middle of the axis flip.
The actual gear shift itself.
Yes. And according to the rigorous calculations provided in our sources, during this exact transitional window when the Great War was fought, the moon's speed was trapped in a chaotic acceleration phase.
And what was the number?
It hit a very specific mathematical number of 2.8 days per nakshatra.
2.8 days per nakshatra. The moon is literally zooming across the sky compared to the old days.
It's moving incredibly fast.
Now here is where we have to play devil's advocate and be deeply skeptical.
Of course.
Because it is one thing to sit in a modern room and propose a 2.8-day lunar orbit, in theory, based on an astrophysical model.
It's a great theory.
It's a brilliant physics concept, but it is another thing entirely to prove it using an ancient text. How do we know this 2.8 number is real and not just retrofitted math designed to make a myth look like science?
We know it is real because the author of the Mahabharata, the sage Vyasa, left us the exact math hidden in plain sight.
We don't even have to guess.
No, we don't. We just had to track a very specific road trip recorded in the text.
You are talking about Balarama's pilgrimage.
Yes. To prove this acceleration, the sources point to a very specific, seemingly mundane story in the Shalya Parva section of the epic.
Right, Balarama, who is Krishna's older brother.
Exactly. As the massive world war is brewing, he decides he wants absolutely no part in the slaughter of his own relatives. Yeah, he's just out.
So he packs up and goes on a grand pilgrimage to visit holy sites along the Saraswati River.
He basically decides to sit out World War Zero and go on a road trip.
A very strategic vacation, yeah. But what matters for our deep dive today is the meticulous, almost obsessive logging of his itinerary by the author.
Right. Vyasa is keeping very close track of him.
Yes. The text explicitly records the exact celestial coordinates of his departure and his return.
Okay, let's hear the coordinates.
It states that Balarama left on his pilgrimage when the moon was positioned in the Pushya Nakshatra.
Okay.
And he returned to the battlefield when the moon was in the Shravana Nakshatra.
Pushya to Shravana.
And crucially, upon his return, Balarama himself states exactly how long the trip took. He announces to everyone, "I have been gone for exactly 42 days.
Okay, let's run the numbers on this because this is where it gets crazy.
To do it.
We have 42 days of total travel time, and we have a set distance in the sky. If you look at the sequence of the 27 lunar mansions, Pushya is the 8th nakshatra.
And Shravana is the 22nd. To travel from the 8th to the 22nd, the moon has to cross exactly 15 nakshatras.
And this is where the elegance of the data reveals itself. You take the 42 days of his trip, and you divide it by the 15 nakshatras the moon crossed.
42 divided by 52.
It is exactly 2.8.
2.8 days per nakshatra. That is the exact mathematical acceleration predicted by the gravitational model.
It is a mathematical bullseye. This is the empirical proof of the gear shift acceleration.
That is just mind-blowing.
It really is. The ancient text is explicitly stating that the moon was traveling at a rate of 2.8 days per nakshatra during the exact window of the Mahabharata War.
Okay, but play devil's advocate for a second again. If I am a modern astronomer or a traditional historian, why hasn't this been noticed before?
It's a fair question.
Why aren't scientists shouting this from the rooftops? Couldn't we just assume Balarama took a longer route, or maybe that the calendar was just different back then?
Well, modern astronomy operates on a strict principle of uniformitarianism.
Okay, let's define that. Uniformitarianism, which means assuming that things have always been exactly as they are right now.
Exactly. Uniformitarianism dictates that celestial bodies have always moved exactly as they move today, without exception.
Right.
So today the moon takes about 1 day to cross a nakshatra. So when modern astronomers and historians read this verse about Balarama, they are utterly baffled.
Because the math doesn't work for them.
Right. If the moon moves 1 nakshatra a day, it should only take 15 days to get from Pusha to Shravana. But the text aggressively insists it turned 42 days.
So what do the modern scholars do with that huge discrepancy? Do they just ignore it?
They essentially try to fix the ancient text to fit their modern assumptions.
Wow, really?
Yes, because they lack the Yugantar model's physics of the gear shift, because they simply refuse to believe the orbit could change, they artificially invent a scenario.
What do they invent?
They argue that Balarama's trip must have taken one full 27 nakshatra orbit of the moon, plus the 15 nakshatras from Pusha to Shravana.
Let me do that math. 27 plus 15 equals 42 nakshatras. And since the moon moves at 1 day per nakshatra today, that equals 42 days.
Exactly. They invent an entire invisible month of travel that isn't anywhere in the text.
That is incredibly arrogant. They are basically saying Vyasa didn't mean what he literally wrote down.
Right.
They are saying we have to add an entire invisible lunar cycle to the text just to make his math work for our modern telescopes.
It's exactly like trying to play a high-definition Blu-ray disc on a 1980s cassette player.
Yes.
You can jam it in there, but it won't play, so you assume the disc must be broken.
I just have the playback speed completely wrong.
Precisely. By ignoring the literal text, they miss the massive astrophysical reality being recorded.
Vyasa wasn't exaggerating. He wasn't exercising poetic license. He was being 100% literal.
Exactly literal. Balarama left on Pusha and returned on Shravana. The moon covered 15 sectors. It took 42 days.
Why? Because the moon was physically moving at 2.8 days per sector due to the gravitational torque of an axis shift.
Exactly. The 2.8 math locks the timeline perfectly.
The math is undeniably solid. I mean, Balarama's 42-day road trip absolutely proves the 2.8 lunar speed. But let's ground this in reality for anyone listening.
Sorry.
Because if the Earth's axis is physically flipping 180 degrees and the moon's orbit is shrinking so fast that it's accelerating to 2.8 speeds, the people standing on the ground would have felt it.
Oh, without a doubt, it would have been terrifying.
It wouldn't just be an abstract math problem floating up in the sky.
Yeah.
If you grab a spinning top and try to force its axis in a different direction, the entire thing shudders violently.
The physical forces would be immense.
Right, so the humans on Earth would have experienced terrifying physical and tectonic and atmospheric symptoms. Does the Mahabharata record a live telecast of a planetary wobble?
It absolutely does.
Yeah.
And with a level of chilling physical accuracy that just destroys the idea that this is all just poetry.
Okay, let's look at the symptoms.
Our sources direct us to the Bhishmaparta section, specifically chapter 2. There we find the description of a phenomenon called Digdaha.
Digdaha, which the sources translate as the directions burning.
Yes. The text describes the sky turning a terrifying, unnatural red. It says the directions themselves seem to literally catch fire, and the earth trembled violently without any clouds in the sky to suggest a normal thunderstorm.
Now, to a poet or a traditional historian, this is just a colorful metaphor for the impending doom of a great war, right?
Exactly. The gods are angry, the earth is shaking.
But to an astrophysicist applying the Yugantar model, this is a literal, highly accurate description of tectonic shock and atmospheric friction.
Yes.
Explain the mechanism behind that, though. How does an axis shift physically make the sky catch fire?
Okay, so if the earth is undergoing a massive gyroscopic wobble, if that bevel gear is actively flipping under the pull of the L2 node, the planet's atmosphere is not going to just smoothly follow the solid crust.
Right, it's a gas. It has different dynamics.
Exactly. The atmosphere is going to experience immense drag. That drag creates hyperfriction.
So it literally heats up.
Drastically. The sky would literally glow red from the torque and the burning of gases in the upper atmosphere.
And the Earth trembling without clouds.
That is not thunder. That is the literal crust of the planet groaning and cracking and experiencing massive tectonic displacement under the shifting gravitational stress.
Wow.
The mantle and the crust are desperately adjusting to a new center of gravity.
And if the physical orientation of the Earth is violently wobbling, the perspective of a person standing on the ground would become completely disoriented.
Completely.
It wouldn't just be earthquakes, the sky itself would betray them.
And the text records this optical betrayal flawlessly. The sources highlight passages where the author explicitly records a sequence where the east and west seem to reverse.
So the fundamental sequence of the cardinal directions just breaks down.
Yes. The data notes that the sun was rising out of place. It was appearing in the wrong part of the sky entirely.
And the text uses a specific term for this, right? Apasavya.
Yes, apasavya, which translates to planets moving in retrograde, appearing to move backward or erratically across the sky.
Because if the Earth's axis is tilting and wobbling rapidly, your vantage point relative to the rest of the solar system is violently skewing.
Your entire frame of reference is pitching.
The apparent motion of the sun and the planets would be entirely distorted. This wasn't a spiritual illusion at all. It was the optical and physical reality of the axis tilting.
Exactly. The 360-day baseline was catastrophically failing.
Which brings us to a puzzle that I found absolutely fascinating in the sources. It is one of the most famous and honestly most debated astronomical anomalies in the entire Mahabharata.
Ah, the 13-day fortnight.
Yes, the 13-day fortnight. Vyasa, the author, makes an incredibly specific astronomical observation here.
It's a crucial piece of data.
He says, and I am paraphrasing the translation here, he says, "I have lived a long time. I have seen fortnights, which is the time between a full moon and new moon, last for 14 days, 15 days, even 16 days. But I've never in my entire life seen two eclipses occur within a single 13-day period."
And this specific statement has baffled modern scholars for centuries.
Because it shouldn't be possible, right?
Exactly.
Yeah.
In a normal, stable orbital system, a lunar phase of fortnight takes about 14.5 to 15 days.
Right.
To have a solar eclipse and a lunar eclipse happen within 13 days of each other is considered physically impossible under our current uniformitarian orbital mechanics.
The geometry just simply does not allow it to happen.
It doesn't.
But, and this is the big but we aren't using current mechanics. We are using the Yugantar model's gear shift. So how does the 2.8 acceleration physically solve this overlapping eclipse puzzle?
It solves it flawlessly when you apply the physics of an elliptical squeeze.
Okay, take me through that.
Remember the figure skater pulling her arms in?
Yeah.
The moon's orbit wasn't just shrinking into a perfect smaller circle. It was being violently squeezed into a sharp elliptical shape by the gravitational pressure of that L2 Lagrange point.
Oh, I see.
Because the moon was accelerating so violently toward that 2.8 speed, its orbital track was severely compressed.
So it wasn't just moving faster, the actual physical track it was running on was shorter and tighter.
Exactly. The moon literally covered 15 days worth of physical celestial distance in just 13 days.
Wow.
The orbital squeeze resulted in a mutated shortened fortnight. The specific spatial geometry required for an eclipse, the precise alignment of the Earth, Moon, and Sun, was compressed in time.
So the alignments happen faster than they should have.
Yes. This resulted in overlapping eclipses occurring within a biologically and physically terrifying 13-day window.
It is the ultimate mathematical proof of a collapsing accelerating orbit.
It really is. It proves the squeeze.
Let's put ourselves in the shoes of the people living through this for a second. The sky is glowing red with atmospheric friction. The ground is shaking continuously from tectonic torque. The sun is rising in the wrong place. And the moon is racing across the sky so fast that eclipses are happening days ahead of schedule, just swallowing the light.
It's apocalyptic.
The entire cosmic system is in a state of violent, chaotic transition. How in the world do you plan a war in the middle of this?
It seems impossible.
I mean, how do you organize millions of soldiers and cavalry and supply lines when you can't even trust the sunrise?
This is where the narrative introduces the figure of Krishna.
Right.
Traditionally, he is viewed as a divine avatar, a philosopher, or, a diplomat. But under the lens of the Yugantar model, Krishna emerges as the ultimate astrophysicist of the era.
He is the master scheduler.
He is. He understands the mechanics of the gear shift perfectly, while everyone else is just terrified by the symptoms.
And our sources point to a specific moment before the war. Krishna is talking to Karna, who is one of the greatest, most lethal warriors on the opposing side.
Yes.
And Krishna doesn't just say, like, hey, let's meet on the battlefield whenever your army is ready. He gives a hyper-specific, astronomically calculated deadline.
A very strict deadline.
He tells Karna that the war must start in exactly 7 days, and it must start on the new moon, specifically when the moon is at the Jeshta Nakshatra.
This is a brilliant strategic and astronomical calculation. Krishna knew that the moon's speed was not normal.
He knew about the 2.8 math.
He knew the exact 2.8 mathematical acceleration was happening. By predicting the new moon at Jyeshta, exactly 7 days out, he is demonstrating an absolute mastery of this new, chaotic orbital math.
He knew exactly where the moon would be, despite the extreme velocity.
Exactly.
But why Jyeshta? Out of 27 possible star sectors, why demand the war start on that specific day?
Because Krishna was deliberately timing the war to align with the absolute cosmic peak of the gravitational tension.
Okay, explain that.
The transition from the Dwapara to the Kaliyuga required the total destruction of the old system, the old political empires, the social orders, and the physical baseline.
Right. The whole 360-day world had to end.
Yes. By starting the war at the precise moment of maximum celestial torque, he ensured that the physical chaos of the heavens would mirror and perhaps even violently fuel the chaos on the battlefield.
We have to test this, though. Let's put this 2.8 math to the ultimate test against the actual narrative of the text.
Let's do it.
The Mahabharata War famously lasts for exactly 18 days. If the moon is traveling at a biologically insane 2.8 days per nakshatra, we can mathematically map the entire war.
We can lay the grid right over it.
So 18 days divided by 2.8 days per nakshatra equals approximately 6.4 nakshatras.
Yeah, 6.4.
So the moon crossed roughly 6.5 star sectors during the entire 18-day conflict.
And when we apply this 6.4 nakshatra grid to the day-by-day events of the 18-day war, the correlation between the celestial mechanics and the human narrative is astonishing.
It really maps out perfectly.
It provides a literal chronological mapping of the planetary gear shift.
Okay, let's walk through it day by day. According to the sources we start with, days 1 through 3, the war begins. The moon moves from the Anuradha Nakshatra into Jyeshta.
Right, this is the entry point into the peak axis wobble. The earthquakes and the Digdaha, the burning directions we talked about earlier, are their absolute height.
The sky is on fire.
The physical disorientation on the battlefield is completely matched by the massive, overwhelming, and chaotic onslaught of the opening battles. Millions of men clashing while the ground shakes.
Then we move to days 4 through 6. The moon leaves Jyeshta and enters the Mula Nakshatra.
This is a critical astronomical juncture in the Yugantar framework. The Mula Nakshatra is aligned with the galactic center, what ancient Indian texts refer to as the Vishnu Nabi.
Okay, what does alignment with the galactic center mean in terms of physical gravity?
Well, the galactic center is the rotational barycenter of the Milky Way. It is a region of immense concentrated mass and gravitational force.
Okay.
When the Earth-Moon system aligns with this center during an already volatile axis shift, it represents the deepest, most extreme point of the 180-degree gravitational pull.
So the planetary bevel gear is at its maximum physical strain.
Exactly. It is the moment the gear threatens to just shatter completely.
And what happens in the text on these exact days? The established noble rules of ancient warfare begin to completely break down.
They throw the rulebook out the window.
The bloodshed becomes lawless and extreme, perfectly reflecting the cosmic strain.
The physics and the narrative are mirroring each other.
Which brings us to days 7 through 9. The moon is moving from Mula toward Purva Ashada. The cosmic tension is peaking. The gear is grinding at its absolute limit.
Right.
And on day 9, we have one of the most iconic, visually striking moments in the entire epic. Krishna, who has sworn a sacred vow not to lift a single weapon in this war, becomes so enraged by the destruction that he breaks his vow.
A huge moment.
He jumps off his chariot, he lifts a massive chariot wheel over his head, and he charges at the enemy commander Bhishma.
Now think about the physical symbolism the author is employing here. Krishna lifts a wheel, a circular gear.
Oh, wow.
In the exact mathematical window when the cosmic bevel gear is experiencing its maximum gravitational torque and threatening to break apart, the master astrophysicist physically lifts a breaking wheel on the battlefield.
That is incredible.
The human narrative flawlessly mirrors the celestial mechanics.
The poetry is the physics. Okay, moving to days 10 through 12. The moon is in Purva Ashada, and on day 10, the invincible enemy commander Bhishma finally falls. He is riddled with arrows and collapses on the battlefield.
And Bhishma is not just a character, he represents the old guard.
Right.
He is the physical embodiment of the Dwapara Yuga, its values, its political power, its ancient stability.
He is the old baseline.
Exactly. His fall on day 10 is the narrative equivalent of the physical collapse of the old Dwapara baseline system. The Kaliyuga's pressure has finally shattered the old world.
Then we hit days 13 through 15. The moon is in Uttara Ashada. This is the most tightly squeezed elliptical part of the orbit. Time is incredibly compressed.
The fastest part of the curve.
On day 13, the young hero Abhimanyu is trapped in a labyrinthine military formation and brutally killed.
Yes.
And then on day 14, we have another famous astronomical event. The warrior Arjuna has sworn a blood oath to kill the man responsible Jayadratha before sunset, or else Arjuna will throw himself into a fire.
A very dramatic ticking clock.
Very. The battle rages, the sun is setting, Jayadratha is successfully hiding, and all seems lost. But then the text says Krishna uses his divine powers to temporarily block out the sun, creating an artificial night.
Right, the famous eclipse.
Jayadratha comes out of hiding thinking he is safe because the sun has set. The sun suddenly reappears and Arjuna kills him.
And for centuries, people have debated this specific event.
Right.
Was it a literal solar eclipse? Was it a divine miracle? A mass hallucination?
Right.
But under the Yugantar model, we see the physical mechanism clearly at work. The moon is at its most erratic, chaotic 2.8 speed. The atmospheric wobble is immense, filled with dust friction and thermal distortion.
So how does an atmospheric wobble bend light to hide the sun? Are we talking about atmospheric lensing here?
Exactly. When you have a massive gyroscopic wobble, the atmosphere compresses and expands erratically. Combine that with extreme thermal friction.
From the directions burning.
Yes.
Yeah.
It creates a massive refractive lensing effect, much like a mirage on a hot highway that makes the road look like water. The physical Earth didn't spin faster suddenly to make it night. The light from the sun was severely bent by the thickened, friction-heated, wobbling atmosphere.
Wow.
Krishna, understanding the exact physics of this atmospheric drag and the compressed orbital timeline, anticipates this optical blackout. He uses the mechanical distortion of the gear shift as a tactical weapon.
He weaponizes the planetary wobble. He knows the atmospheric refraction is going to cause a blackout, and he uses it to win the battle.
He does.
Finally, we reach days 16 through 18, the bloody climax of the war. The moon arrives at the Shravana Nakshatra. On day 18, the war officially ends. And wait, hold on.
Look at the data points.
Oh my gosh, if you were listening to this, the math just closed a massive loop.
It's beautiful.
We established earlier that Balarama, the brother who avoided the war, went on his road trip. The text says he left on Pusha and he returned on his 42nd day of travel.
Right.
And the text specifically notes that he walked back onto the battlefield on the 18th and final day of the war. And Balarama noted that on that specific day, the moon was in the Shravana Nakshatra.
The celestial coordinates perfectly align.
The 18-day war chart, which we just calculated, moving at exactly 2.8 days per nakshatra, lands perfectly on the Shravana star sector on day 18.
Yes.
And Balarama's 42-day road trip spanning 15 nakshatras also lands perfectly on Shravana on the exact same day.
It matches flawlessly.
Both independent accounts, the violent timeline of a massive war and the quiet timeline of a guy walking along a river, are held together by the exact same 2.8 mathematical thread. It flawlessly syncs.
It is the ultimate mathematical verification of the model.
You can't fake it.
You cannot fabricate two divergent, highly specific narrative timelines that perfectly intersect at the exact same celestial coordinate unless both are operating under the exact same literal physical reality.
Right.
The 2.8 days per nakshatra acceleration is not a theory. It is an empirical fact encoded into the text.
The precision is just staggering. Okay, so the gear flipped, the axis shifted, and the war ended. But the physical Earth wouldn't just instantly snap back to normal, right?
It takes time.
If you slam the brakes on a speeding car, you still skid. The kinetic energy has to dissipate. How long did it take for the wobbling planet to finally settle back down to its calm 4.709 baseline?
This brings us to the post-war timeline. And it is just as meticulously recorded in the astronomical data as the war itself. We have to trace the deceleration phase, the bleeding off of that kinetic energy.
Okay, let's lay out the timeline after the war ends. The war concludes on a date known as Kartik Purnima.
Right.
Following the slaughter, there is a massive period of mourning. The survivors spend 30 days on the banks of the Ganges River performing rites for the millions of dead. It is a full month of pure grief.
It's a very dark time.
Then, after that 30-day period, the victorious King Yudhishthira returns to the ruined capital. His grand coronation takes place under the Pusha Nakshatra.
And this coronation is a crucial data point for our astrophysics manual. During this time, the solar system is still in the throes of the flip.
The narrative sources actually note that during the coronation, the atmosphere is still filled with fear and turbulence. It's not described as a happy, peaceful, stable event at all. The Earth is still unsettled.
Because the physical deceleration hasn't finished yet. The planetary break skid is still happening.
Right.
During the coronation, the moon was still locked into that chaotic 2.8 speed.
Mm.
The calculations in the source material map this out. From the pre-war buildup to the coronation, the moon is still racing. The transition is highly active.
But then after the coronation, Yudhishthira and his brothers go back to the battlefield. They go to sit with a dying enemy commander, Bhishma.
Yes.
Remember, Bhishma fell on day 10 of the war, but he possessed a unique boon that allowed him to choose the exact time of his own death. So he is physically lying there on a literal bed of arrows for weeks.
Waiting.
And he proceeds to give Yudhishthira massive sweeping lectures on politics, morality, and cosmology.
Vishnu is waiting. He is purposefully delaying his death for a very specific astronomical event. He's waiting for the true Uttarayana.
Let's define that. Uttarayana, the sun's northern path opening.
Yes. In ancient Indian astronomy, the Uttarayana is the 6-month period when the sun appears to travel northward on a celestial sphere.
Okay.
It is traditionally considered the most auspicious time to die, representing the path of light, the clear Earth-Sun-Heaven path. But here's the critical issue. Because the Earth's axis was physically flipping, because the bevel gear was still in violent motion, the true direction of the sun was totally distorted.
Right. If the Earth is wobbling, the sun appears to be in the wrong place. Bhishma couldn't just look at a traditional calendar to know when Uttarayana started.
No, the calendar was entirely broken by the axis shift.
He had to physically wait for the planetary compass to stop spinning. He had to wait for the wobble to end.
And the text gives us the exact duration of his wait. He explicitly states that he laid on that bed of arrows for 58 nights.
58 nights.
And our sources point out something absolutely vital here. He doesn't say 58 days. He specifically uses the term for lunar nights, chandratitis, not solar days.
Why does that distinction matter so much? Why nights instead of days?
It is paramount.
Yeah.
By deliberately counting lunar nights, he is tracking the moon's phase and its speed. He is completely ignoring the chaotic, distorted solar days caused by a wobbling Earth.
Ah, I see.
A solar day is dependent on the Earth's rotation relative to the sun, which is currently compromised. A lunar phase is a more stable metric for him to track the deceleration. He is not a dying man counting sunsets. He is a scientist observing a planetary deceleration curve.
So let's trace the math of this deceleration skid. We know the speed was 2.8 during the war and the coronation. How long does this transitional wobble last in total?
The sources calculated beautifully. From the coronation at Pushya to Bhishma's death, if we assume the 2.8 speed held for a while as it slowly began to lose momentum, it equals about 82.6 days.
Okay.
Add the 14 days prior to the coronation, and you have roughly 97 total days of transition.
97 days.
A 97-day window where the cosmic wobble was slowly, agonizingly bleeding off its immense kinetic energy.
As Bhishma is giving his teachings from a bed of arrows day after day, week after week, the cosmic wobble is finally beginning to slow down. The atmospheric friction is decreasing.
Exactly. The extreme gravitational torque from the L2 point is lessening as the solar system settles into its new orientation.
Pressure is lifting.
The moon's orbit, which had been squeezed incredibly tight into that ellipse, begins to relax. It starts to widen back out toward a more circular shape.
Okay.
And as the orbital radius widens, the conservation of angular momentum dictates that the speed of the moon across the sky must begin to slow down. It decelerates from 2.8 to 3 to 4.
And when does it finally stop? When does the gear shift officially end and lock into place?
We have an exact mathematical anchor point. The Yugantar calculations reveal that just 2 to 5 lunar nights before Bhishma finally passes away, around the specific astronomical date of Magha Shukla Ashtami, the flip completely ended.
Wow.
The massive 180-degree turn was complete, the axis stabilized, the true Earth-Sun-Heaven path, the genuine undistorted Uttarayana, finally locked into place.
And right at that exact
moment, the moon's orbit widened back to its full extent, and its speed locked securely back into the 4.709 days per Nakshatra resting pace.
the original baseline.
Yes. The new baseline, or rather the return to the old stable mathematics, was fully achieved.
If you are trying to picture this deceleration, think about spinning a coin on a hard table. When you first spin it, it's a blur of chaotic speed and it's wobbling violently all over the place.
Right.
That is our 2.8 speed. That is the war. The atmospheric friction, the overlapping eclipses. But as the coin loses kinetic energy right before it stops completely, the wobbling slows down. The sound it makes against the table changes.
It settles.
It settles, and finally it just drops flat on the table, totally still.
That is a perfect visualization of the gyroscopic decay.
Bhishma wasn't just stubbornly waiting for a religious date on a calendar to arrive. He was physically, bodily waiting for the gyroscopic wobble of the Earth to stop.
He was waiting for the cosmic coin to drop flat.
Once the planet settled and he tracked the lunar speed hitting exactly 4.709, again, he knew the physical path was finally clear, the torque was gone, and he allowed himself to leave his body.
A beautiful synthesis. The spiritual weight recorded in the epic was in reality a profound astrophysical observation of orbital stabilization.
So what does this all mean for you and me? Let's bring this home. We just took one of the world's oldest, most revered epics, a text famous for its poetry, its chariots, its philosophy, and we ran it through a rigid, unyielding mathematical physics model.
And it survived.
Not only did it survive, it proved itself. It proves that these ancient minds weren't just writing flowery metaphors about angry gods. When they said the sky was burning, they meant literal atmospheric friction.
Exactly, literal friction.
When they said a guy took a 42-day trip, they were mathematically proving a 2.8-day orbital acceleration. They were recording a highly complex celestial deceleration event, an entire planetary axis shift, with jaw-dropping mathematical precision.
It completely revolutionizes how we must treat ancient information. We can no longer afford the historical arrogance of modern uniformitarianism.
Right.
The assumption that the ancients were simply primitive people, frightened by normal thunderstorms writing fairy tales. They possessed a highly sophisticated framework of planetary mechanics, the Yugantar model, the cyclical engine of gravitational torque, that allowed them to map the heavens and survive during a catastrophic planetary crisis.
It forces us to ask a really massive question, and this is the final provocative thought I want to leave you with today. We have just used these sources to prove that the Mahabharata contains a mathematically sound, day-by-day orbital map of a planetary axis shift, recorded entirely without telescopes, without satellites, and without modern supercomputers.
All done with human observation.
So what else are we misreading? What other myths, what other dragons in the sky, or great floods or wars of the gods across global cultures, from the Maya to the Sumerians to the ancient Egyptians, are actually precise, empirical astronomical data logs?
That's the real question, isn't it?
How many other cosmic manuals are sitting on our library bookshelves right now, mislabeled as fiction, just waiting for someone to find the right mathematical key to decode them?
It is a profound mystery. And it deeply suggests that the physical history of our solar system is far more violent and human memory far more accurate than we ever dared to imagine.
We started this deep dive talking about reading ancient history like a broken X-ray machine looking at diagnostic muddy waters. But it turns out the X-ray wasn't broken at all. We just didn't know how to read the film.
We had the wrong lens entirely.
Thank you so much for joining us on this deep dive into the Yugantar model and the hidden physics of the Mahabharata. Keep questioning the uniform assumptions around you, keep looking for the hard data hidden in the poetry, and we will see you next time.